In this example, we're going to take a look at something called rotational speed or angular speed. And it's denoted by this lowercase letter omega, which kind of looks like a W. So, as you can see, we have the was actually one form of the angular speed. This record spins at 33 revolutions per minute, which you might be familiar with as RPMs. Um, the what they want us to find this angular speed in is radians per minute. So we need to figure out how many radians this record spins in a matter of time. So the formula for angular speed is essentially the theta, or the angle that's traveled, in the unit of time, t. So to get that angle in radians, what we're going to need to do is determine how many radians this record spins in 33 and a third revolutions. So if every revolution takes up 2 pi radians to complete, that means what we're going to do is take 33 and a third times 2 pi. So as far as units go, we can say 33 and a third revolutions times 2 pi radians in one revolution, to make it hopefully make a little more sense why we're multiplying it by 2 pi. So looking at our calculator, 33 and a third in decimal form will of course be 33.33. Then we're just going to take that number times 2 pi, which is going to give us 209.44 roughly radians. So we'll say 209.4 radians. And then we want radians per minute, so that means it just takes 1 minute to go that many radians. So we're going to get 209.4 radians per minute. There's one other formula we can use to translate this angular speed, in other words, how many rotations we have per minute, to a linear speed. And the formula we're going to use is V equals R, or radius, times omega. And the linear speed is the radius, which they give us the diameter. That means our radius, which is the diameter over 2, ends up being 30 over 2, or 15 centimeters. So we'll simply take 15 times our angular speed, which we found to be 209.4. And notice we've got centimeters. I should have wrote that in there. And we've got, for our angular speed, we've got radians per minute. So this is essentially going to give us centimeters per minute when we take 15 times 209.4. We get 3141 centimeters per minute, but we want centimeters per second. So what we'll do is we'll take this, and we want our minutes to cancel out. So we know there's 1 minute every 60 seconds. So our minutes on the bottom and the top cancel out. We divide 3141 by 60, and we get 52.4 centimeters per second. And that would be my linear speed. So now see if you can figure out the angular speed of a carousel if you're given the diameter of 6 feet and the rotation of 10 revolutions per minute.